Hello, everyone. So, we are now going to continue with chapter 2 for the MyLab IT access portion. Okay. Chapter 2 is about table designs, creating tables, relationships between tables, um, and simple queries, and the query wizard. So here's what we're going to be starting with for chapter 2 in this video. Okay, yes. Our chapter 2 objectives for this video, which is the first video, will be to create and modify tables and work with data types, primary and foreign key, which is the need for a primary key and a foreign key when building relationships, establishing table relationships, referential integrity between relationships, which is relationship properties, types of relationships, one-to-many, many-to-many, and one-to-one, creating a single table query and using a query wizard to create a query. So to get started here, if you recall that a table is a collection of records, with each record made up of a number of fields. During the table design process, consider the specific fields you will need for each table. List the proposed fields with the correct tables and determine what type of data each field will be storing. So will that field be a number field, a date field, a picture field, a text field? The order of the fields within the table and the specific field names are not significant at this stage, as they can be changed later. As long as you have the framework of the database tables, and each table needs to be broken down into smaller pieces of information. So to the smallest possible piece of information, and then each of those pieces of information will be a field within your table. The smaller the fields, the easier it is for you to then down the road use these fields to build queries. So your queries can be built in to give you very detailed information. Take, for example, a table that stores customer information. Now, when you start a table for customer information, your first table will probably need to be about customers' contact information. So it'll be first name, last name, and the address. If you only put a field and call it address and put the entire address into it, it'll be very difficult for you down the road to break that down into area of the city, province, and any further detail about postal code and stuff like that. So if you want to do a query on how many customers do you have from the northwest or from the southwest of the city, that wouldn't be possible, because that piece of information needs to be in a field of its own in order for you to query that field. Therefore, you will break the address down sorry, into maybe street, so the number and the street of the address. City will be a field of its own. State or province will be a field of its own. The zip or the postal code will be a field of its own. Phone number, if there's two phone numbers, you'll have two fields with phone numbers, maybe primary and secondary, or work and cell, however you want. So if you notice, each of these little pieces of information should be in a field of their own. So that's very important when you're designing your table. Now, when you're storing data in their smallest parts, you must remember that the data that you're storing should be grouped. So each table should deal with a specific grouping of information, a specific category. So take, for example, customers. I'm going to open up the customer table here. This is one group of information, or it's all about customer, the customer's information, right? Now, If you have, in this database, which we have up on the screen, we have three tables. We have accounts and branch. So you can see the database is related to a bank. Notice in the top you have the database name right on the top of the screen. It's about a bank. You have the accounts, you have customers, and you have branch. We could put all of this into one table. We could have the customer's information, we could have the branch information for each customer, and we could have the account ID and the account balance, the date the account was open, all in one table. That would be no different to an Excel spreadsheet. We don't want an Excel spreadsheet. We want a database table. Therefore, each of the pieces of information that you're going to store will be grouped into categories. The first category here is about customers. The second is about the customer's accounts. And then the third is about the customer's branch. Or no, not the customer's branch, but the branches, right? So the branches that they have listed here is branch location, uptown, eastern, western, southern, and campus, and then the branch manager, and then the manager's start date. So it's about the branch. Here you have about the accounts. You notice you have customer ID, and here too we have a field customer ID. So this customer ID and the accounts table customer ID field is the same. I'm going to go into the design view for the customer table here by right-clicking on the tab and saying design view. Notice that the customer ID is a number field. Down here in the properties, we have a field size of a long integer, and we have a format of general number, which you can change by clicking on the down arrow. And we have decimal place as auto. We have customer ID as a caption. So whatever you put on here, however you break this up into 1 or 2 words if you like, that will show as your column heading in the table. I'm going to go back to my datasheet view. You notice here you have customer ID, exactly how it is in the caption, in the properties, in the design view right here. However, up here in the design view field name, you should have no spaces. Having spaces takes up place. It's a character. It takes up space in your database. In your field names, you want to minimize that by either putting a underscore. So if you wanted to have an underscore and then another letter or another word, that would be considered one word, but no spaces. Here in the caption, you can put a space so that it is easier for your users to know what you're doing here. So just like that. Okay, so now here I want to tell you one more thing. If you use a number data type and a long integer right here, these properties must be the same in the table that you're going to link to it. So here we have accounts. I'm going to go into design view. And you notice this is the primary key, and then you have a secondary key, which is customer ID. It is similar to the customer field. It is also given the data type of a number data type. Okay, long integer. It has a general number for the format, auto decimal, and the caption. Okay, so that's linked to the need for a primary and a foreign key, or sometimes called a secondary key within tables. What is a primary key? When designing your database tables, it is important to determine the primary key, meaning that that primary key will uniquely identify each record in the table. Okay, so if I click here and go into my design view, I don't think I want to save any changes, but I'll just do that. Okay, I'm going to go into my datasheet view here, and notice that each record within my customers table has a ID, right? The ID identifies uniquely this customer. This ID number, the customer ID number, is the unique identifier, right, for the customers table. Now, you must plan for common fields between tables. In the customers table, I have my customer ID as my primary key. I have primary key. Designate the selected field or fields as primary key right here. And then if I go into my accounts table, I have the customer field here too. This is the foreign key, meaning it's linked to my customers table, but in the customer table it is the primary key, customer ID, and the accounts table customer ID is not my primary key, it is the foreign key, but these two fields are linked. Okay. As you create tables and fields for the database, keep in mind that some tables will be joined in relationships using common fields. Therefore, the customer ID from the customers table and the customer ID from the accounts table will be joined together. This creates relationships and will help you extract data from more than one table at a time when creating queries, forms, reports, etc. Let's close out of all these tables here, and I will then show you under your database tools, you have relationships. This is your relationship board. By clicking on it, you'll see what relationships have been built within this specific database. This is the first thing you would look at in whichever database you'll be working with. So if you're at work and you have a database that you have to deal with, if you have access to know which relationships have been built behind the scenes, it will give you the ability to then create more efficiently queries, reports, and forms. This is my customers table, this is my accounts table, this is my branch table. You can move these around by selecting the bar, the title bar, and dragging. So accounts table, I will put it this side. You have your customer ID here. This is the one side of the relationship. That means that this relationship here between the customer ID in your customers table and your customer ID in the accounts table is a one-to-many relationship where customer ID in the customers table is the primary key and the unique identifier, whereas customer ID in the accounts table is the foreign key and does not have to have only one customer ID or one arm. It is not unique. It has many. So each customer has many accounts, but each customer has only one record in the customers table, whereas in the accounts table, the account ID is the primary key, which means in the accounts table, the account ID field is your unique identifier. You will not find two of the same number within the accounts field. Okay. If I go into the table design for accounts table, here you notice account ID is the primary key, designated as the primary key. I will open it up in datasheet view. Each of these records is unique. There will be no duplicates in your primary key. If it is a primary key for the table, there cannot be any duplicates in it. If it's the foreign key, you can have duplicates. So I'm going to go back into design view here, and when I put my cursor in account ID, in the account ID field, right here, go down here and look at what it has. No duplicates. So we're indexing it so that we can use it for easy queries and filtering, etc. However, you must say no duplicates. I will now look at the same primary key in the customers table right here. Go into design view. And here too you have no duplicates. However, in the accounts table for the customer ID field, duplicates okay. That is because it is the many side of the relationship. It allows for duplicates within that field for the accounts table. Okay. So, avoid data redundancy, which is the unnecessary storing of duplicate data in two or more tables. You don't want to have, in your accounts table, you don't need to have data which is already stored in the customers table. So for example, in the customers table, you have the customer's first name and last name. In the accounts table, you have your customer ID, which identifies each customer that you have in the customer table. You don't need to have the customer's first name and the last name in both fields. That would be data redundancy. Having redundant or duplicate data in multiple tables, that means repeating different fields in multiple tables, can lead to serious errors. Suppose the customer's address data, which was stored in the customers table, and if you store it again in the accounts table, so if you store first name and last name or an address in both these tables for each customer, and then a customer changes his last name, you will have to go in and change it in two places. If it's only changed in the one place, so in the customers table, but not in the accounts table, you will have a problem. If you run a query using your accounts table, you'll have wrong information for the last name. Similarly, if the address is duplicated, that wouldn't be efficient as well. So therefore, when choosing a design for your database, you must make sure that any fields you have should only be shown once in any of the tables, and they should not be in multiple tables. You don't need to repeat information. That's redundancy. The other thing that you need to keep in mind is when building a table and choosing a primary key. Right? You should not, or you definitely should not choose a primary key for a table that would change over time. For example, it might seem pretty normal. Okay, let's use last name for a primary key for the customers. So what happens then if a customer or two customers have the same first and last name? You then have a problem because your primary key must be unique. However, last names are not unique. You could have several Williams and several Scotts, or you could have several Khans or Singhs. They are not unique, therefore cannot be used as a primary key. Okay. Now, in that case, sometimes what you could do in some situations, you could use two fields and have a primary key for those fields, using two fields, which is kind of a combination of fields and reduces the possibility of duplicates, and which could be used as a primary key. But if possible, try to have a ID number or a auto number, something that definitely will not clash over time or will not change over time, right? Because say, for example, you think that in the accounts table, instead of using a different account ID, why don't they use the customer's bank account ID? Well, or bank card number, right? Let's say bank card or Visa card number or something. Customers sometimes lose their Visa card or want to shut down an account and start a new account. In that case, you will lose all the information when you delete the customer's account. Therefore, having a unique, completely independent number, or which will not change over time, which has no possibility of, you know, redundancy or duplicates, that's the best way to choose your primary key. The other thing you need to remember when designing a database is to accommodate for calculations. So let's take, for example, the balance. It's a currency, right? You could do various calculations on currency, right? And you might want to. Therefore, you must make sure that it is either a currency or a number, whichever one makes more sense at the time, when you have the possibility of doing calculations based on that field. Okay, calculating fields are frequently created in database objects with numeric data, such as, say, monthly interest, right? Um, the monthly interest field that multiplies the balance of a customer's account, say, by 1% each month, right? Which would be a field which you could call balance, and you could then use that balance to do calculations in a query. So what you would do, you would take the balance field and multiply it by 0 or 0.01 for a 1% interest, right? Or if not interest, maybe a fine, maybe whatever calculations you might want to do. You can also create calculated fields using a date time. Here we have the open date, which is basically the date that the customer opened that account, right? So what type of calculation would you want to do, or what type of calculation might you want to do on a date field? For example, if you want to store the length of time a customer has had an account, right? You can create a calculated field that subtracts the opening date. So subtract the opening date from today's date. That would give you the number of days that the customer has been an account holder within the bank, right? So for example, sometimes banks do give rewards, or they might give a special a golden or a platinum card to only customers who have been with them for a certain number of years. They might have to use their database to do some calculations based on the customer's opening date of opening their account with the branch. A person's age is another example of a calculated field. Using date arithmetic, the date of birth is subtracted from today's date and the result is divided by 365. Now you might say, why put the date in by the date of birth? Why not by the years? Because if you say the age, every year you need to have a macro in the background that will track the birthday on that day, change that field every year, which is possible, which is doable, but that means that there's more work involved. Why not just put the age based on the date of birth year? Okay, so that gives you a little idea of how you would, if you needed to, how you would design a database. I am now going to close out of these tables here and go back to our relationships. Okay, so look at the relationships one more time. Now, this is a one-to-many, meaning that in the customers table, the customer ID will be very unique, will have no duplicates. Whereas in the accounts table, each customer will have several accounts. By double-clicking on the joint line, this is your joint line. Double-clicking on the joint line, this is your relationship window. Here you can change relationships. So if I click on the link here, it tells me the other tables that are within the database in case I want to change it. I'm going to leave this and then show you here. You have your branch, and you also have a branch ID here, which means that here in the branch table, the branch ID is the one side of the relationship, and the many side of the relationship again is in the accounts table, because that tells you which branch that account is in. So in the branch table, let's open up the branch table here. You have the branch ID, the manager name, you have the location, and you have the start date. So this is the start date, and it gives you, putting a description helps users of a database understand what that field data is all about, or what it holds, right? Here you have a caption, manager start date. So the caption shows up in the field heading, the title right here, manager's start date, so that you don't confuse it with the customer start date or the account start date. Okay, close out of that. Back to our relationships window, right? The other thing you need to know is, so if I open up, I can right click or I can double click. So this time I just right clicked on the joint line, and it allows me to open up, edit the relationships here. Enforce referential integrity, right? What referential integrity is a very important part of a database. To go back to primary key, right? We talked about primary key. So the primary key is the field, or possibly a combination of fields that uniquely identifies each record in a table. Access does not allow that each table Access does not require that each table have a primary key. You can have a table without a primary key. However, a good database design usually includes a primary key in each table. You should select unique and infrequently changing data for the primary key. Okay. You could also have an auto number. So if you don't want to set, or you don't want to designate or assign a field as a primary key, you could have access to that by just numbering 1, 2, 3, 4, 5, and that's automatically done every time you create a new record within a table. It is a auto number. So if I say I want to create a new table, I'll go to create, I'll go to table right here, and then click to add, right click. I could choose if I want to make the primary key an auto number. Where am I looking here? I could go number, and I could just say customer number. Okay. Now if I go into design view, I'm going to give this table, go into design view, take that out here, and here I have an auto number. It gave it the table, the new table I created automatically gave a auto number to the field, right? And this auto number data type right here, and customer number is another number, or customer ID. I could change this to customer ID. So now my customer ID is not my primary key. My ID, just ID, I could change this to customer number, right? So that's another way to, when you start a table, if you don't want to designate a specific field as the primary key, you can allow access to give your table a primary key and make it an auto number. I'm going to close and say no. Okay, so that's the primary key, and if you want to use a auto number, it's doable. So for example, let me give you an example here where you might want to use an auto number. Say you're building a database at home, say you're building a database to track all your tools or recipes or something that you have, or a collection, maybe some kind of hobby that you might have, vinyl records, and you don't really think that you need each to have a unique name. You just want a list of everything that you have within your inventory. So you would allow for an auto number, and every time you buy a new tool, or you start a new recipe, or you buy a new vinyl record, all you have to do in there and start typing in the name, and Access will automatically give it a auto number or a number. So, in order to share data between two tables, the tables must share common fields. The common field will generally be the primary key in one table, and the same field in the adjoining table will be denoted by a secondary field or a foreign key, just like we have here for customer ID and customer ID. And then if I double click on there, I know you can see here this is the primary, this is the both fields have the same name. One is in the customers table, one is in the accounts table. But this side, the one on the left, is your primary table, or your one side of the relationship, and the second one is the many sides. It's not necessary that it'll be a one-to-many relationship. You could have different join types. You have three possible types of join lines. We'll get to that in a minute. Before I get there, let me talk about the three types of relationships. So you have three possible types of relationships: a one-to-one, a one-to-many, and a many-to-many. So the one-to-one relationship, basically both tables will have a primary key, which will be the unique key in both tables, and that's the one-to-one, means in both tables that key will have unique records and will not be duplicated. The one-to-one relationship, to give you an example, sometimes, so let's take an example of, say, an IT department, right? An IT department may have um, what would we say, client information, right? So it might have client information. However, the client information will have two parts to it for each client. One part of the client information will probably deal with the client's basic information, which everyone can have access to. So basic information related to the client's name, the client's location, the client's title, the client's phone number, all of that stuff. But the other part of this client information would be more sensitive, right? It could be passwords, it could be um, confidential information related to the client's access within the department. So that part of that information will be in a separate table. However, again, there can be a one-to-one relationship between these two tables. So let's say we have clients' general information, and then we have clients' confidential information, right? Each client will have only one record in both of these tables. There's no way that a client can have more than one record in either of these tables. Therefore, there'll be a one-to-one relationship between these two tables. The other type of relationship is a many-to-many. A many-to-many relationship is seldom used, but it's more of a it's very, very uniquely used. And what happened is you construct a new table when building a many-to-many, kind of a middleman table, right? This is an artificial constructed relationship allowing many matching records in each direction between both tables. So both tables can have many records for that primary key. However, they're joined in a third table, and that third table will have only one primary key for each of those records. For example, a database might have a table for employees on one side, and then another table for projects. So several employees might be assigned to one project, but one employee might also be assigned to several projects, right? So several projects to one employee and several employees to one project. Therefore, the many-to-many relationship. Okay, so to build a relationship, all you have to do is I'm going to delete this relationship right here and rebuild it. So I've deleted it. We don't have the relationship between customers and accounts now. Without this relationship, we cannot query or build a query to pull information from both these tables and put it into um, into one report, right? So I want to build, I know that I have a customer's ID, and that's a primary key by the key sign that is beside it. Whereas here in the accounts table, I also have a customer ID, but I do not have a key sign. Therefore, I know this is the one side of the table and of the relationship, and this will be the many side of the relationship. What I do is I will select, press down on the left side of my mouse and drag. And as I go into the accounts table, it changes. The cursor changes to a plus, telling me yes, I can add this if I want. When I move my finger off my mouse, it takes me to the edit relationship window. It has here the basic information. However, enforcing referential integrity is a very important part of building relationships between tables. Enforcing referential integrity basically is, as the name suggests, the two tables will refer to each other. When I click that, it gives me two more options, right? Now, the referential integrity basically does not allow you to delete one side of the table without deleting the other side, or adding information to one side without adding information to the other side. Referential integrity enforces a rule in a database that is used to preserve relationships between tables when records are changed. Right? When referential integrity is enforced, you cannot enter a foreign key value. I'm going to do that. Say create here. So I cannot go and enter a customer ID into my customer field without having a customer ID in, and the information with that record first entered into my customer table. So the side which is the primary key of that relationship must have a record first before you can add the foreign key table information. So before I can add anything about the account, I need to go in first into my customer table, add first name, last name, street, city, state, zip, etc. And then once I have a record in for a new customer, in my customers field, I can go ahead and assign an account side of information. So I can assign a branch ID, I can assign account ID, branch ID, balance, open date for that customer, right? That's what the enforcing referential integrity basically is. So when referential integrity is enforced, you cannot enter a foreign key value in a related table unless the primary key value exists in the primary table. Okay, the other thing here is cascade update related fields and cascade delete related fields. So if I have information on a customer ID in the customer side and I make a change to my customer side, automatically anywhere else within these two tables which are connected, the changes will apply. Any change that is made on one side will apply to the other side as well. The delete, if I delete a customer from my customer ID side, it will also, all the information related to that customer will be deleted from the account side. But if I go into my accounts table and I delete information from my accounts table, I'll get an error. The error will tell me that I cannot delete information from the account side before I delete the customer information. Okay, so you cannot delete information from the foreign key or the foreign table without deleting it first in the primary, and therefore cascade delete related records. If I delete something in my primary table or my customers table, it will automatically be deleted from the accounts table as well. Most of the time you will want updates to be taken care of for you. but not necessarily um, for deletes. So for example, if I'm using this relationship between customers and accounts for queries as I have right here, right? I have a query here which is pulling account ID, customer ID, branch ID, and balance. So this is pulling information from all three tables. Now, if I go in and I change, if I go into my, say, my branch table, and I say, you know, this manager or something has changed within this manager's record, it will automatically change that in the other tables as well. So maybe a better example would be in my accounts table. If you go back into my query here, and you notice the icon is different for the query and the tables. So in my query, look at the account here, you have your balance, right? So this field has been used for this query. It has a balance for each of the customers, and then it also gives me the account ID, right? So now I know that from my account table, it has the balance information. The branch ID is from the branch table, right? And then go back in here, and of course the customer ID is also from the customer table, and then the account ID from the account table. If I go back into my accounts table, or maybe my branch table, if I open up this little plus sign, it shows me how many different records I have within this Kirby Uptown branch. So in the Kirby Uptown branch, which is branch 10, these are the different customers within the branch 10 that is listed here, and each of their balances, and as well as each of their open dates. So that's the magic that happens when you have a relationship between tables. Let's open up the customers table here, and if I open up a customers record, so 3001, I'm opening up that customers record, it tells me here that this customer has got 1, 2, 3, 4, 5, right, account IDs in various branches, so various branch IDs has these balances in each of their accounts, and this is the open date. So that's the magic of a relationship, having that ability to look at each one and all of the information from all the other tables just by looking at one table. I'm going to close all here. Okay. So we were talking about setting cascade options, right? Go back into my database tools and relationship window. I'm going to open up edit relationships, and you notice here you have a relationship between the branch table and the accounts table. From the branch table you have branch ID, and from the accounts table you have account ID, where the branch ID is the primary, and then from the accounts ID, the branch ID field is the foreign key there. You have enforced referential integrity, so both they're referring to each other, and you can use information from both these tables to pull queries, reports, and forms, and then you will cascade update related fields. So the cascade related update field option, when you check that off, so that when the primary values modified in the primary table, Access will automatically modify or update the foreign key value as well. For example, if I have a branch ID that's changing, right? If I change the branch ID in my branch table, automatically the branch ID will also change in all the tables that have foreign keys related to the branch ID. So the branch ID in any table that is related to the primary table, which is the branch table, will automatically be updated. Similarly, if I delete a branch ID from my branch table, it will also be deleted in the accounts table. Okay, that is if I check this out. Again, it's a one-to-many relationship. Okay, so that's on relationships and how relationships work. As you move into doing stuff, you'll understand better what the purpose of all of this is. I'm going to X out from here, and I'm going to get out of everything. And let's just go in and do a simple exercise, which is basically going to cover all that we did in this video right here. So to start with, we will start a new access table, access database. I will go in and type in access. When you type access into your search option on your computer, it will give you the ability to start a blank desktop database. By clicking on it, here it says blank desktop database, and you will give it a name. Okay, so let's say we want to start a blank database desktop just for the one that we just did. We will call it bank underscore and put your last name. And then say create. This is what you'll get. You'll get a, by default, you'll get a table in datasheet view and the ability to start fields within that table. Let's click on the click to add, and then let's say we want to give it a name which is a text and which is going to be a short text. We'll say short text, and it tells you, okay, so what you've given the field a data type. Now you have to give the field a name. Let's call this branch ID, and then tab. It automatically goes to the next available field, right? And it gives you a list of the data types. For this one, we're going to make this into our manager field, right? So we'll select short text again, and we will name it manager. And then we go tab, takes you to the third field. Let's call this, let's make this also a short text because we're going to use location, and name it location. Now, if we click the first column, the ID field, right here, let's click in here, and then we press tab. It'll take us to the next, and then the next, and the next, and the next, and then you can add information as you see fit, right? So what we basically are going to do here is click the first column, the ID field, next to the new record asterisk, and press tab, and then let's say we don't want this, so I'm going to delete it. So I'm going to click on the top here, right click, and I can say delete field. But if I want, I can also go into design view. So just with the skeleton here, I'll go into design view. You will need to name the table before you do anything else, right? So let's name this table and say branch. And now we are in design view. We saved it as branch, right? And now we're in design view, and I want to delete this. I'll right click it, select it, right click it, and say delete from here. I could also just put my cursor in here and say delete from the ribbon. Deleting the field requires Microsoft Access to delete the primary key. I will say yes. And now I have no primary key. However, I do need a primary key, and I'm going to make my branch ID into my primary key. So the branch ID field, make sure your cursor is in the branch ID field and click the primary key option in the ribbon. Now, how long would a branch ID be? By default, a branch ID wouldn't be that long. So let's go in here and say we will make it 15. But remember, whatever you put here, you're going to have to use the same properties anywhere where you have your branch ID because it's a primary key. In all the foreign keys for the branch ID, in whichever number of tables you're going to link this to, the properties must be the same. So I've given it short text, I've given it a field size, okay. I could go into caption, and I don't want branch ID to show, I want it to have a space in between. So I'll say branch space ID. That will be the column heading. And now here, no duplicates is automatically the default because it's the primary key. Manager, again, I don't need the manager's name. The manager's name couldn't be as long as 255 letters, so I'm going to say 25. And then here, as a caption, I will say manager's or branch manager's name, let's say. Okay. Location, I don't need 255, I could make it again 25 and give it a caption. That's fine. Location, branch location, that could be the caption. I will save these changes and then go back into datasheet view. Now I have my field headings as shown in the caption for each field heading property. Okay. So let's start typing something so you know how to type into a table. You know that you're in this record. You have nothing in this table now. You know that you're started to insert information into this record because you have a asterisk on the side here. So my first branch ID will be B10. The name is Krebs, the branch manager's name. Uptown 12/3/2000. Oopsie, sorry, I did not put date there. So I'm going to go back in here and add. I'm going to go back in here and add a date field, date time, and this is going to be my manager's start date. Now, when I type that in here, if I go back into my design view, you notice it has spaces. I don't want those spaces. I'm going to remove that. That's automatically going to, it should not be here. It should be in the start date here, but I'll go into the caption here and I'll put in, now I'll be fine. Save those changes and go back into design view. And now I have the option of either going into my date picker, which probably not the easiest way. Easier way is to just type it in right here. My second branch is B20, unique, because it's my primary key, right? And then Esposito is the branch manager's name, Eastern, and 6/18/2013 is when he started. Third record I have B30, and the name is AMOAKO. And then the start date for this guy is 13/2011. The fourth, we have Sing Southern, oops, not Southern, sorry, my mistake, B40, Sing Southern, and 9/15/2014. One more to go. Thanks for your patience. and you can put your last name. Let's put my last name here, campus, and let's say, so that's how you would populate a table. Once you've populated a table, you can go into your design view, make sure that everything is okay in your design view. Look at the, let's go in, you have that here, and say I want to change the format for my date pick, for how my date shows. I have these options right here. So for the date, a short date is how I have it now. I could change that depending on how I want it to appear. I don't think I want any other. I just wanted to leave it as short date. However, if you would like it to be a long date, you could choose long date here, save, go back into your datasheet view, and you'll have the long date. But you see how long it becomes and how much space it takes up on the screen, right? Even you might want to do that if it's too much. But yeah, I'd rather have it show up as a short date. So I'm going to go back here and say short date and then save. Then go back into my datasheet view, and now I have it as my short date. To close out of a table, you could either right-click right on here and say close, or you can go to this X. So it says close branch, say yes. Okay, now I'm going to open it from here again. Go back, you can open it. That's one way of opening it. You can select, you can double click. There you go. You can open it that way too. Close, or you can just go right click here and say open. You can open it in either view as well. So when you right click on the object, you have the option of opening it in design view, or if you say open, it opens automatically by default in datasheet view. Okay, so that's all we can get through in this video. I think I went over for a couple of objectives, so we might have actually done a few of our next video objective as well. Oh, well, I could also go ahead and create a single table query and create a query using Query Wizard. Maybe I'm going to move these two objectives right here and add them to our second video, because this video is already looking pretty long to me. Okay. Well, I hope you were able to get the idea of how to build relationships within a table, what is the primary key, what is the foreign key, what is data referential integrity, cascade update, and cascade delete, as well as the different types of relationships between tables, the one-to-one, one-to-many, and many-to-many. The one-to-many is what you're going to see most of all in this course. However, you might come across the others, although rarely. Okay, thank you, and let's move on to the next one. Before you move on to the next video, go through this video and also go through the learning activities on MyLab IT under the Learning Resources folder, so that you get some practice on what we just learned.